Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2022 paper 1. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 1 says two stable isotopes of helium are helium-4 and helium-3. An atom of helium-4 is produced in a rock that contains uranium. It is produced following the radioactive decay of uranium-238 atom. The decay also creates an atom of thorium. Write an equation for the decay of uranium-238. So in the question it is given to us thorium is produced in this decay and also helium-4 is produced. Helium-4 is produced. Now we need to find out atomic number of thorium and mass number of thorium. We need to understand for any radioactive decay, mass number on both sides should be the same. So here we can find out first of all mass number, and the mass number of helium is 4, so this one has to be 234. So the mass number of thorium is 234, and atomic number of thorium we have to find out now. Atomic number on both sides also has to be the same. So we have 92 and we don't know what is the atomic number of thorium, and we have atomic number of helium, that is 2. So this one has to be 90. So simply we can write on here this is 90. So this is how you can answer this type of problems. Question 1.2 says a helium-3 nucleus can be produced by the decay of a tritium nucleus. State and explain which exchange particle is responsible for this decay. In order to answer this question, first of all we need to understand it is what kind of decay. Is it alpha decay? Is it beta decay? Is it gamma decay? So we can start with this information. It is given to us that tritium nucleus, heavy hydrogen isotope, this can produce helium-3. So we have helium-3. So this is helium-3. So it can produce helium-3. Now if you look at mass number is the same. There is no change in mass number. So it means that it cannot be alpha decay. Now if you look at atomic number, means the number of protons has been increased, but mass number remains constant. It simply means that neutron has been changed into proton. So we can say in this case neutron has been changed into proton and the charge has been increased. So here charge is +1, here we have +2. To conserve charge it should be beta minus decay. As beta is a particle, so there will be electron anti-neutrino. So this is electron anti-neutrino. Neutrino has no charge and neutrino has negligible mass. So from here now we can say this is beta minus decay. In this case it means that leptons are involved because electron, this is a lepton. As leptons are involved in this case, it means that this is weak interaction. So this is weak interaction because weak nuclear force is responsible for this decay. So this is weak interaction. As this is a weak interaction and charge is -1, so it means that exchange particle in this case has to be W minus. So this is our exchange particle, or simply you can say this is boson. So this is exchange particle involved in this decay, means responsible for this decay. So these are the things you need to understand to answer this question. This question has 2 marks, so you have to state first of all what kind of exchange particle, then you need to explain. So 2 points you have to mention. So if you write down in your answer these 2 points, you will get 2 marks. Exchange particle is W minus because this is weak interaction. So this is our statement, and this is our explanation. explanation. So if you have written these 2 points, you will get 2 marks. Question 1 theory says, before helium was identified, some scientists suggested that the lines of the helium spectrum seen in the absorption spectrum of the sun were due to the presence of sodium and hydrogen. Means before helium was identified. So scientists, they suggested that the lines we see, some lines, unknown lines we see in the spectrum, absorption spectrum of the sun, those lines are due to the presence of sodium and hydrogen. For this question, we need to discuss with the reference to the lines A to F in figure 1, the evidence for and against this suggestion. Quite straightforward question. Simply we need to look at figure 1 and we need to write down in support of this suggestion and also against this suggestion. So the best way to answer this question is we can draw the lines. So if I draw a line from here, so this is over line A, we can draw the lines. From B we can also draw the line, so this is B, and from C we can draw the line here, and from D we can draw the line, so we can draw these dotted lines. From E we can draw this dotted line here, and from F we can draw this dotted line here. Now if you look at these lines, we can see A is not, the line A line is not matching with sodium, is also not matching with hydrogen. B is also not matching, so we can say B is also not matching. We can cross this one, but C is matching, so we have C here, and also we have C in hydrogen. D is also not matching, so we can say D is also not matching. E is matching, so we have E here, and also we have E in sodium. F is also not matching with sodium and hydrogen. So it means this is in favor of this suggestion, and this is also in favor of this suggestion. And F, D, B and A, as they are not in sodium and also they are not in hydrogen, it means they are against this suggestion. So simply we can say in this case, as line C is in helium and also in hydrogen, so it supports the suggestion. And for this one we can say as line E, this is in helium and also in sodium, so it supports the suggestion. And for line A, for B, for D, for F, we can say as these lines are not in sodium and hydrogen, so these lines do not support the suggestion. So this is, we need to write down in our answer. Now let me show you how you can write down your answer in a proper way. In your answer you can mention these points. Line C is in both helium and hydrogen spectra, so it means it supports this suggestion. Line E is in both helium and sodium spectra, so it also supports the suggestion. But line D, we can also say line D, line A, line B and line F, as they are missing from both hydrogen and sodium spectra, so these lines do not support the suggestion. So this is how we can answer this problem. Question 1.4 says, calculate in electron volts the change in energy level responsible for the spectral line labeled E in figure 1. Means for this line. Here we are talking about absorption spectrum. So we can draw these lines, few lines here. These are energy levels. We can imagine this is n is equal to 1. So imagine that when electron was here, this electron will absorb certain photon of certain energy. That energy, let's say, is equal to delta E, and this electron will jump to high energy level if energy difference is equal to the difference between these two energy levels. This electron will jump from here to here. Question is asking us to calculate that value of delta E, mean the energy of this coming photon. So how we can calculate? In order to calculate energy of this absorbed photon, we can simply use Hc over lambda. We need to calculate delta E in this case. H is equal to 6.63 times 10 to minus 34 joules seconds, and C is a constant, 3.0 times 10 to 8. So value of lambda we need to find out. To find value of lambda, simply we can draw this dotted line here, dotted line here. So this is the dotted line. Now here we have 550 nanometer, and this is 600. Now if you look at this one, this is about 1/5, means this is about 590 nanometers. So simply we can plug in this number here, 590 nanometers, and if we solve this one, we will get 3.37 times 10 to minus 19 joules. This is in joules. We need to convert this one into electron volts. We need to understand 1 electron volt is equal to 1.6 times 10 to minus 19 joules. So we need to convert into electron volts. So we can simply write down here 3.37 times 10 to minus 19 joules multiply by. So we need to get rid of joules. So joules has to be here. So 1 electron volt, so this is 1 electron volt divided by 1.6 times 10 to minus 19 joules. Now we can simply cancel this joules with this joule, and if we solve, we will get our final answer, that will be equal to about 2.1 electron volts. So this is this one, because these two are the same. This is in electron volts, this is in joules, because 1 electron volt is equal to this. So simply you can write down 1 divided by 1 means 1 electron volt divided by 1.6 times 10 to minus 19 joules. And if we simply solve this one, our final answer will be equal to 2.1 electron volts. This is very powerful tool. Let me give you another example. Let's say we have 10 kilometers per hour. We need to convert this one into meters per second. So how we can convert? We can write down first of all kilometer per hour. Now we need to get rid of kilometers, so simply we can write on here, this is 1 kilometers, we need meters. 1 kilometer is equal to 1000 meters. Now we have hours, we have to get rid of hours. We can write on 1 hour here, and 1 hour as how many seconds? 1 hour has 60 minutes and 60 seconds. So if you solve, you can cancel this kilometer with this kilometer, this hour with this hour. So if we solve this one, you will get your final answer in meters per second. So this is one way to convert units, but this is very nice method. If you stuck, you don't know how to convert units, you can simply use this one. Question 1.5 says, explain with reference to the processes within an atom the difference between an emission spectrum and an absorption spectrum. So if you look at these two spectrums, so the first one is the absorption spectrum. So we can say this one is absorption spectrum because we see these dark lines mean these missing wavelengths. So this one is absorption spectrum. And this one is the emission spectrum because we see these colored lines on this dark background. So this one is emission spectrum. For this question, we need to explain with reference to the processes within an atom, means what is happening inside the atom. And this question has 3 marks. So for absorption spectrum, so when the light is coming, these certain photons, they are coming. If the energy of this photon is equal to the energy difference between these two energy levels, this photon will be absorbed. If the energy of this photon doesn't match, let's say the energy of the photon is equal to this energy difference, this photon will not be absorbed and it will just pass through this atom and will pass through this gas. And if the energy of this coming photon is equal to the energy difference between these two energy levels, this electron will absorb this photon and it will jump to this level. So it will be in excited state. And for absorption, when electrons they are already, this is the next process now these electrons are in excited state, so they will when they will de-excite, they will emit those certain photons again. So this electron jump from here to here, it will emit certain photon equal to the difference between these two energy levels. Then this electron will de-excite, it will emit certain photon equal to the energy difference between these two energy levels. So these are the points we need to understand to answer this question. Now let me explain you this one in detail so you can understand absorption spectrum and also you can understand emission spectrum in detail. So first of all, if we look at absorption spectrum, you need to understand when white light passes through cold gas, it simply means that you can imagine we have white light, means it consists of all colors, and it passes through a gas cloud, and after this one the light there will be some missing wavelengths, and those missing wavelengths we will see in form of dark lines. So this is first one, it's telling us electrons absorb energy from photon. Means photon will be absorbed, electron will jump from low energy level to high energy level, so those photons will be missing from this light. The second point, electrons move to high energy level, as we have already discussed. Energy of photon is equal to difference in energy levels. Since energy levels are discrete, light of a particular wavelength is absorbed. Means electrons will only absorb certain photons of certain wavelengths depending on its energy levels, difference between energy levels. When electron de-excites, it release photons. Electron de-excite, it release photons in all direction. Means when this gas will cool down, it will emit photons in all different directions. So these photons will not reach here. We have observer at this point. They will not reach this observer. So that's the reason we will see the dark lines, creating dark lines on continuous spectrum. So this is what you need to understand about absorption spectrum. Now let's try to understand about emission spectrum. For emission spectrum, we need to understand these electrons in hot gas, electrons are at higher energy levels. So these electrons, they are in excited state. So we can simply say this is in excited state. So electrons are in excited state. During de-excitation, electrons release energy in form of photons. So they will release energy in form of photons. Here they absorb photons. Here they absorb, and here they release of specific wavelengths according to a colored line. Each line corresponds to a discrete energy change, means jump from one energy level to another energy level, discrete. Emission lines that correspond to specific wavelengths are observed, that correspond. So based on this energy difference, we will see certain line. Let's say this line is representing one energy level and this line is representing an other difference in energy levels. So we will see certain photons. So these are the points you need to understand about emission spectrum and absorption spectrum. I hope these points make sense to you.